Today we'd like to get ready, prepare for the binomial probability formula. There's some terminology. Factorial. Example, 3 factorial. Start with the digit 3 and descend down to the digit 1, forming the product. 3 times 2 times 1, which would be 6. 7 factorial would be starting with 7. 7 times 6 times 5 times 4 times 3 times 2 times 1. Using your calculator, you get 5,040. Let's try another one. How about 4 factorial? Starting with 4, we have 4 times 3 times 2 times 1. Well, 4 times 3 is 12, times 2 is 24. If we were to do that on our calculator, let's say we had 9 factorial. On my TI-30XS, if I turn it on, if I want 9 factorial, I'm going to put in 9, the PRB key, and then I have options. In option 3 is the factorial, and then I hit enter. I'm getting the answer of 362,880. Let's try another one, a little simpler one. How about 6 factorial? I'm going to hit 6, the PRB key. Looks like I have to have option 3, enter, and I'm getting 720. Okay, next thing. We want to talk about the number of combinations. When we're talking combinations, order of events does not matter. Versus permutations, the order does matter. The long formula is the number of combinations of a sample of n with x successes is equal to n factorial over n minus x factorial x factorial. N is the number of trials, x is the number of successes. Let's try that with this problem. We want the number of combinations with 5 events with 2 successes. Let's do it longhand before I show you how to do it mathematically. Well, we could, the number of successes, we could have a success of 1 on the first pull, success of 1 on the second, success of 1 or success of 2 events. 2 events success, 1 event success. 2, 2, 3, 1, 3, 2, 4, 1, 4, 2, 5, 1, 5, 2. Notice we don't have 1, 4 because 1, 4 and 4, 1 are the same digits, but in opposite order, where combinations order does not matter. So we only list it once, not twice. Okay, plugging into the formula, 5 goes in the numerator, factorial, divided by the difference between 5 and 2 factorial times 2 factorial. Doing that out, 5 factorial is 5 times 4 times 3 factorial. 5 minus 2 is also 3 factorial. 2 factorial is 2 times 1. These can cancel, and then I have 20 divided by 2, or 10. Well, we can always do it that way, but it's much shorter using calculator. And I'm using my TI-30XS calculator. We're going to use the PRB key. And when we hit that key, we're going to have some option. Option 2 is calculating the number of combinations. Option 3 is calculating the factorial. So let's try the number of combinations of 5 events with 2 successes. So I'm going to put in the 5 first, the PRB key, option 2, the number of successes is 2, enter, and I come up with 10. How about the number of combinations of 7 objects with 4 successes? Put in 7 first, PRB, option 2, put in the number of successes 4, enter, and I come up with 35. Let's try a couple other ones. How about 7 events, number of combinations, 7 events with 3 successes? Okay, What I'm going to do is put in the number of events, which is 7, hit the PIB key, option 2, and then I want 3 successes, enter. I'm coming up with 35. Let's do one more. How about the number of combinations of 8 events taken with 4 successes? 8, PRB, option 2, 4, enter, came up with 70.